Welcome to Module 4 of this beginner cybersecurity course. In this module, we'll be exploring network fundamentals, a cornerstone topic in cybersecurity. Why is this important? Because most cyber attacks, from phishing to ransomware, exploit network communications in some way. By the end of this module, you will understand how devices connect, how data flows, and how attackers take advantage of those systems. Whether you're just starting out or looking to reinforce your foundations, you're in the right place. Let's dive in. So by the end of this module, you'll be able to define what a network is and how devices communicate, explain IP addressing, DNS, ports and protocols, understand how network models help security monitoring, use Wireshark to capture and interpret traffic, and apply this knowledge in a hands-on project. Let's begin with the basics. What exactly is a network? A network is a group of interconnected devices, computers, servers, routers, that communicate with each other to share resources. Think of it like a city-wide postal system. Each device has a unique address, its IP. That data gets broken into packets like letters, parcels, that get sent between homes. This communication structure is what we rely on daily, but it's also what attackers exploit. Every device connected to a network has an IP address, a unique numerical label used for identification, but we rarely type IPs directly into our search engines. Instead, we use domain names like google.com, instagram.com, facebook.com. That's where the domain name system or DNS comes in. It acts like an internet phone book, translating human-friendly names into IP addresses. As a cybersecurity professional, be aware that attackers can manipulate DNS to redirect traffic to malicious sites. It's a tactic called DNS spoofing. Now, imagine visiting an apartment building. The IP address gets you to the building. The port number gets you to the right house, apartment, or service. For example, port 80 is HTTP, port 443 is HTTPS, port 25 is SMTP, is Secure Mail Transfer Protocol. Now, protocols like TCP and UDP decide how data moves. TCP is reliable like a phone call, and UDP is fast but less reliable, it's like sending postcards. To understand how data moves through a network, we use reference models. The OSI model has 7 layers, from physical wires to the apps we use every day. The physical layer of the OSI model transmits raw bit streams over physical mediums like cables, radios, or fiber optics. Data link layer packages data into frames for transmissions and handling error detection and MAC addressing. Network layer determines the best physical path for data to travel using logical addressing like IP. Transportation layer ensures reliable data transfer with error checking and flow controls, example TCP, UDP. Session layer manages, opens, and closes communication sessions between applications. Presentation layer translates, encrypts, and compresses data to ensure it's reliable by the receiving system, while the application layer interfaces directly with the end user. It is what you see. Applications to provide network services like email, file transfer, and web browsing. The TCP/IP model is also another reference model, but it simplifies these layers into 4 layers. As a cybersecurity professional, we pay special attention to layer 3, 4, 7. Layer 3 is the network layer, layer 4 is the transportation layer, and layer 7 is the application layer. Why? Because these layers are where attackers and defenses are the most active. Subnetting is like dividing a large city into small districts. It helps organize and isolate traffic within a network. For example, a 24 subnet provides 256 IP addresses. That is more than enough for a small office. Subnetting improves performance and contains security incidents like limiting how far malware can spread within a network. Firewalls are the gatekeepers of the digital world. They determine what traffic is allowed or blocked based on rules like IP addresses, port numbers, behavioral patterns. Now, there are two main types of firewalls: host-based firewalls like Windows Defender, Zone Alarm, and uncomplicated firewalls, and network-based firewalls like Cisco ASA, Fortinet FortiGate, and Palo Alto's Networks Firewall. Proper configuration is key, both in blocking threats and in avoiding disruptions. Logs are the fingerprints of network activities. As an analyst or a cybersecurity professional, log data is your best friend. Look at firewall logs for blocked connection, DNS logs for suspicious lookups, and proxy logs for unusual browsing. Security tools like Wireshark and Zeek help you capture and analyze the data in real time, like you can see. Now let's apply what we've learned with a hands-on traffic capture using Wireshark. Here's what you do. You first open up Wireshark, let it load up. Then you select your network interface, whichever one you want to capture traffic through. So I'll be selecting Ethernet cable. Then you start up your capture. So as you can see, it's blank, meaning no traffic is coming through there. So we'll open up our browser and just search for something. So I'm just going to type fast.com here. And this is so you can generate some traffic to capture. Okay, so we'll go back to Wireshark. And as you can see, Wireshark is color coded. Different colors mean different things. Light blue TCP, dark blue DNS, green is HTTP, black are packets with error, light purple is for TCP control packets, and I think gray is for ICMP traffic or other general traffic. So we're just going to filter for DNS. Yeah, so you can see all the DNS traffic that has gone, that we have captured with their source IPs, the length, and other information. Now I'm filtering for HTTP. So we can see the OCSP response and the HTTP response. So this just shows more additional information. You can see the source IP here and destination IP, destination ports, and additional information here. So this task just mirrors what SOC analysts or cybersecurity professionals do on a daily basis, capturing traffic and analyzing the logs that come in through those traffic. Wow, you've completed module 4. Let's recap what we've learned in this module. You now understand networks, IPs, ports, and protocols. You can interpret the OSI and TCP IP models. You've practiced log analysis and used Wireshark for real-world packet capture. These skills form a critical foundation for threat detection and incident response. In the next module, we'll build on this by introducing you to the world of malware, how it behaves, how to identify it, and how analysts detect its presence through behavioral and signature-based clues. Thank you, and see you in the next video.